Right now, 8 feet below your home, the ground is holding at 55 degrees. Not approximately 55, not somewhere between 50 and 60. 55 degrees, locked, stable, season after season, summer heat wave after winter deep freeze, unchanged by anything happening on the surface above it. The soil at that depth does not know what month it is. It absorbs the seasonal temperature swings of your climate the way an ocean absorbs a single stone dropped from a pier. The energy disappears into thermal mass so vast, so ancient, and so indifferent that the surface disturbance never reaches the bottom. That is not a metaphor. That is measured, documented, reproducible physics, confirmed by NOAA ground temperature databases, by USGS soil thermal mapping, by university monitoring programs running across multiple decades, and by the simple fact that every cave, every root cellar, and every buried structure in the temperate world stays cool in summer and frost-free in winter without a single watt of electricity. The biggest thermal battery in the world is already installed beneath your foundation. It has been there longer than your house. It costs nothing to access. And the industry that sells you mechanical cooling has spent 70 years making sure the conversation never started. 2,400 years ago, Persian engineers in the desert cities of Central Asia solved the problem of summer using exactly this principle. They pulled air through underground kanat channels, clay-lined tunnels dug 6 to 15 feet below the surface, where the earth held the passing air at roughly 55 degrees even when the ground above baked at 100 degrees or more, and they drove that conditioned air upward through wind catcher towers rising above the roof line using nothing but pressure differentials and the natural movement of wind across a parapet. No fuel, no machinery, no moving parts, delivering interior temperatures that travelers and chroniclers of the period described as genuinely surprisingly cold. The HVAC industry made sure you never learned about it. By the end of this video, you will know exactly why earth-coupled cooling was buried, and how to build your own ground-coupled ventilation system for under $500. I'm your host, and welcome to this channel. Subscribe so you never miss what the energy industry hopes stays underground. To understand why your attic insulation money is being wasted, you have to go back to that desert, to a civilization that understood something about physics that the modern construction industry has systematically erased from contractor training, building codes, and the mental model of every homeowner alive today. The Qanat system of ancient Persia, documented in archaeological records spanning centuries and now protected under UNESCO heritage designation in Iran's Yazd province, was not a primitive workaround invented by people who had no better option. It was precision engineering calibrated to a physical constant. The builders understood empirically, if not in the mathematical language we use today, that below a certain depth the ground temperature stabilizes at the mean annual air temperature of the region, that the earth itself becomes a thermal battery charged over geological time, indifferent to seasons, and available to anyone willing to dig a trench and lay a channel. The tunnels ran for hundreds of feet beneath the desert floor. The intake sat in hillside shade where the air was already cooler than open desert. The air moved because warm air rises and cool air sinks, because wind catcher towers created a low pressure zone at the building's exit point, because the physics required no permission from any authority to function and asked for no monthly payment to continue. They solved summer entirely, without a single moving part. Here's the number that changes everything. The principle behind the Qanat is not geography specific, not climate specific, not ancient civilization specific, and not dependent on any technology that did not exist in 400 BCE. It is a universal physical constant called the thermal diffusivity of soil, and what it states is that the amplitude of surface temperature fluctuation decreases exponentially with increasing depth until at roughly 6 to 10 feet below grade, the seasonal swing essentially vanishes. Lord Kelvin studied ground temperature gradients in the 19th century. Modern ASHRAE ground temperature databases confirm what Persian builders discovered by digging. The soil at 8 feet depth holds approximately the mean annual air temperature of the region, year-round, without exception, without utility bills, without maintenance cycles. In Climate Zone 5, which covers a broad band of the American Midwest and Northeast, that number sits between 52 and 56 degrees, every month, every year, without deviation. The Earth does not need a thermostat, it is one. The embarrassing truth, the truth that no mechanical contractor will put on a quote sheet, is that this principle has never stopped working. It was working when the Persians dug their first channels. It was working when the Romans built their frigidarium cold rooms and fed them with underground air passages carved from stone and lined with clay, running beneath the thermal mass of imperial bath complexes across the empire, documented in Roman construction surveys, and confirmed by archaeological excavations from Britain to North Africa to the Levant. It was working in Song Dynasty China, where palace construction accounts describe underground cooling corridors integrated into imperial residential compounds, channels designed not for water but for air, deliberately routed through deep soil before entering inhabited spaces. The Romans and the Chinese and the Persians never compared notes. They arrived at the same engineering answer independently because physics only has one answer to the question of where cool air comes from in a world without machines. An idea so obvious, every advanced civilization independently discovered it. The pattern does not stop at 3 civilizations, and this is what makes it truly remarkable and what makes the modern absence of this knowledge so staggering. In North Africa, Berber communities in Matmata, Tunisia built troglodyte houses carved directly into rock, with underground room temperatures that ethnographic studies have measured at readings dramatically lower than surface air during peak summer heat. In Afghanistan, the ancient Kharez tunnel irrigation system, a cousin of the Persian Qanat, doubled as a passive thermal infrastructure for communities built along its path, providing cool air as a byproduct of its water-carrying function. In the American Southwest, indigenous cliff dwellings used the thermal mass of sandstone overhangs and subterranean room placement to maintain habitable interior temperatures through extreme high desert summers that regularly exceed 100 degrees at the surface. None of these cultures consulted each other. All of them found the ground. Every civilization that faced heat independently arrived at the same answer. Only one civilization forgot it. Then something happened. And this is where the story changes from physics into politics. In 1902, Willis Carrier filed a patent for mechanical vapor compression cooling. Within 50 years, the entire infrastructure of American residential comfort had been rebuilt around a machine that required electricity to start and a utility company to sustain indefinitely. The commercial rollout of mechanical air conditioning was not merely a product launch, it was the construction of a dependency, and dependencies generate revenue in a way that a buried clay pipe simply cannot. Mechanical systems required certified installers, licensed contractors, refrigerant supply chains, annual service contracts, replacement components, and above all, a monthly utility bill that passive earth-coupled systems are structurally incapable of generating. Carrier Corporation records and the trade publications of the 1940s and 1950s document an industry that actively shaped building standards, trained a generation of contractors exclusively on mechanical systems, and cultivated relationships with the regulatory bodies that would define what a compliant, insurable, financeable American building looked like for the next 70 years. No conspiracy meeting was called, no document was signed ordering the erasure of earth tube cooling. They simply built a world where it was never mentioned, and a world where something is never mentioned eventually becomes a world where it is not known. The disappearance accelerated during the suburban construction boom of the post-war decades, and this is where the suppression becomes visible, not in documents, but in the physical shape of the buildings themselves. The standard American tract house of the 1950s and 1960s was poured on a concrete slab. The slab eliminated the crawl space and the basement that would have provided a natural and inexpensive integration point for any earth-coupled ventilation strategy. FHA and HUD housing standards of the era, which governed what builders could finance and what buyers could insure, treated the mechanical HVAC system as the baseline structural assumption of residential construction. Passive earth coupling was not explicitly prohibited. It was simply never given a checkbox on any form that mattered. Contractors learned what the codes required, and the codes required ductwork, mechanical units, rated equipment with model numbers, and service panels with certified access. The building inspector who arrived at a job site carried a form with boxes for refrigerant line sizing, filter access specifications, and equipment clearance measurements. There was no box for a 40-foot buried HDPE pipe running from a north-facing hillside intake to a rim joist penetration. The passive system was not disproven by science. It was excluded by the administrative architecture of a construction industry that had already committed its education, its liability structure, and its supply chain to the machine. The attic became the battlefield. The ground beneath you was never invited to the fight. In the 1970s, the oil embargo briefly forced a reckoning. Energy researchers at Oak Ridge National Laboratory and the University of Illinois, working under Department of Energy grants generated by the political crisis of fuel scarcity, studied earth-air heat exchangers as part of a broader emergency investigation into passive building systems. Pilot installations were built and monitored over multiple heating and cooling seasons. The data was documented in DOE technical reports that still exist in federal archives. The systems performed. Incoming ventilation air temperatures were measurably and consistently reduced before reaching mechanical HVAC units, cutting compressor runtime, reducing peak load, and extending equipment service life. The data was good. The oil price collapsed in the mid-1980s, the political urgency evaporated with it, and the research was shelved. The institutional memory of those studies did not transfer to model building codes, to contractor licensing curricula, or to any consumer-facing publication that a homeowner might encounter when planning a renovation. The passive solution went back underground, this time not into the cool soil where it worked, but into archive boxes where it accumulated dust alongside other ideas that threatened a profitable status quo. What arrived next was not passive ignorance, but active friction, and this is the part they cannot explain away. In the 1990s and 2000s, as indoor air quality became a regulatory category, the legitimate concern about radon gas infiltration in certain high radon geological zones was systematically applied as a generalized argument against underground air intake systems across all soil types, all geologies, and all geographies regardless of measured radon levels. EPA guidance documents, ASHRAE ventilation standards, and insurance underwriting policies that required documented brand name equipment combined to create a regulatory environment in which an earth tube ventilation system required engineering variances, custom geotechnical approvals, and liability language that a standard mechanical HVAC quote did not need and could not accommodate within a normal construction timeline. The radon concern is real in specific places. Radon mapping is freely available from the USGS. A homeowner can test their soil before digging a single foot of trench, but a real and solvable risk in 10% of sites became a bureaucratic wall erected across 100% of permits. The moisture and condensation concern raised against buried air pipes is equally solvable. A slight downward slope on the buried run directs condensate water to a low point drain fitting, and a particulate filter at the intake prevents biological accumulation inside the tube. These solutions are not experimental. They are described in installation documentation used in European certified buildings, but no code pathway existed for them in American residential construction, and without a code pathway, no bank would finance the system and no general contractor would accept the liability of installing it. It was not destroyed. It was made inconvenient to approve. That is the precise mechanism of structural suppression, and it is more durable than any conspiracy because it requires no ongoing coordination to maintain. Meanwhile, in Germany, Austria, and Switzerland, none of this particular institutional history applied. The Passive House Institute in Darmstadt, founded by physicist and building scientist Wolfgang Feist in the early 1990s, developed a rigorous, monitored, third-party verified building performance standard that treated earth-air heat exchangers as a standard certified component of the passive building thermal envelope. The German installation specification calls for 200mm HDPE pipe burial at between roughly 5 and 6.5 feet of depth, run lengths of 30 to 50 meters, with condensate traps at low points, intake filters rated for particulate and biological load, and annual visual inspection as the complete maintenance requirement. Monitoring reports published by the Passive House Institute document inlet to outlet air temperature reductions of between 14 and 22 degrees Fahrenheit across summer operating seasons, measured over multiple years in schools, hospitals, office buildings, and single-family residences. More than 50,000 certified Passive House buildings globally include earth-air heat exchanger installations with documented, publicly available performance records. The proof is not theoretical, it is in 50,000 monitored buildings. The data is free to download. The knowledge was simply never imported to a country whose construction industry had already decided what a compliant building was allowed to be. Here is what this means for the house you are standing in right now, because this is where the ancient principle becomes a weekend project. A functional earth-air heat exchanger built to basic residential performance standards uses 8-inch corrugated HDPE drainage pipe available at any building supply warehouse, buried in a trench 6 feet deep, running 40 feet from an intake point on the north or permanently shaded side of the structure to an exit point through the rim joist or a low foundation wall penetration. The intake requires a downward-facing 45-degree elbow to shed rain and debris, a fine mesh screen to exclude insects and rodents, and a removable filter housing for periodic cleaning. The buried run needs a continuous slight slope toward a condensate drain fitting at the lowest point of the run. The exit delivers preconditioned air into the basement, crawl space, or directly into a low return air plenum where it enters the building's circulation without bypassing any filtration already in place. The system operates in silence. There is no compressor, there is no refrigerant, there is no service contract, no model number for an insurance form, and no monthly utility charge attributable to its operation because it uses no electricity. In summer, ventilation air that would enter your home at 88 or 90 degrees surface temperature arrives at the building envelope having shed 10 to 15 degrees Fahrenheit of heat during its 40-foot transit through soil held at 55 degrees. In winter, incoming air that would arrive near freezing is pre-warmed by the same mechanism, reducing the heating load on whatever mechanical system you keep for peak demand. Current material pricing for a complete 40-foot installation with proper fittings, filter housing, condensate provisions, and intake protection runs between $300 and $600. One weekend, one trench. No permit required in most jurisdictions for passive ventilation operating below 50 cubic feet per minute. Everything the industry told you was complicated is sitting on a shelf at a building supply for under $500, waiting for someone to remember that the Persians already figured this out. The reason you insulate your attic first is not that attic insulation is the most effective intervention available. It is that attic insulation is in the code book on the contractor's standard quote sheet, eligible for the utility rebate program, and fully compatible with the mechanical system already consuming electricity in your equipment room. Attic insulation addresses somewhere between 15 and 20% of summer heat gain in a typical residential building. The earth beneath your foundation addresses incoming ventilation air temperature at the source, reducing the thermal load that the mechanical system must condition every hour it cycles. One approach exists because it fits the approved administrative architecture of residential construction. The other approach was removed from that architecture before most living homeowners were born. But here is what physics cannot erase, what no building code and no trade association and no utility company incentive structure has ever actually changed. The ground temperature has not moved. The number the Persian engineers built their Qanat system around in 400 BCE is the same number sitting in the NOAA ground temperature database and the USGS soil thermal map today. 55 degrees at 8 feet of depth, steady, patient, and utterly indifferent to the market forces that spent 7 decades pretending it was irrelevant. The earth was holding that temperature before your house was built. It held it before the suburb was platted. It held it before the first mechanical cooling patent was filed, before the first utility company strung its first wire, before any inspector arrived with any form that had no checkbox for a buried pipe. It is holding it right now, beneath your foundation, beneath the slab, beneath the insulation, and the ductwork and the equipment that runs on electricity you pay for every month. The pipe does not know it is the 21st century. The earth does not either. 55 degrees, 8 feet down, right now, still working.